Those who are online are able to hear me?
Yes, sir.
Yes, sir.
Okay. We shall get started. All experiments done. Start on live. Say that. ஒரு பிரச்சனை இருக்கு இது நாட்டில் வேலை செய்யுது சரி ஒன்று பண்ணலாம் நான் இந்த கிளாஸ் நார்மலாக போயிடுறேன் ரெக்கார்ட் பண்ணேன் பட் வாய்ஸ் வந்துட்டு 1 minute guys, we are almost started. We'll get started. Oh. Guys, those who are online, you are able to hear me?
So yes, sir.
Okay.
Yes, sir.
1 minute. Perfect. Okay. Yeah. Brilliant. So in a previous lecture, what did we discuss? So in a previous lecture, we were discussing about the dot product, or we also called it as scalar product of two given vectors. So in this class, we are going to see the next part of this chapter. That is, we are going to see what is vector or cross product. So the name of the topic is So the name of the topic is vector or cross product of two vectors. So when we saw the dot product of two vectors, we understood this thing. If there are two non-zero vectors, A and B given to us, that is A vector and B vector are given to us, then A vector dot B vector was defined as magnitude of A vector into magnitude of B vector into cos theta, where theta was the angle defined between those two vectors. In a similar context, if you try to find out what exactly cross product of two vectors means, the definition goes like this. Vector or cross product is defined as the vector. So cross product gives you a vector output. That is why it is also called as vector product. So it is defined as the vector whose magnitude. Remember, it is going to give you a vector. So vector has both magnitude and direction associated with it. But in this definition, we are only going to talk about the magnitude of the output that the cross product is going to give us, right? So whose magnitude is equal to the product of the magnitudes of two vectors and sine of the angle between them. So when you talk about the dot product, you talk about cos of the angle between the given vectors. When you talk about cross product or vector product, you talk about the sine of the angle between the given vectors. So if you observe the diagram, it is going to look something like this. So cross product is a vector whose direction is perpendicular to the plane of two vectors and is given by a rule called as right hand, for which first let's see how the diagram is going to look like. So the diagram will look something like this. So if I have A vector and B vector, which are inclined to each other at an angle theta, then mathematically you will write if you define theta as the angle between A vector and B vector, then you write the cross product in this way. A vector cross B vector is given as magnitude of A into magnitude of B into sine of the angle between these two vectors multiplied with a unit vector which is called as n cap. Right? So n cap is basically a unit vector, but the question is, when you say it's a unit vector, how are you going to define the direction of the output? So I repeat, how are you going to define the direction of the output? And the direction of n cap is given in which direction? It is perpendicular to whom? It is perpendicular to the plane that is containing these two vectors, A vector and B vector. Means if the board is considered to be the plane which contains A vector and B vector, then n cap will either be in the direction towards you or will be in the direction into the plane of the board. So that is how the directions are divided. That is how the directions are defined. Okay, and how to find them? It is found by using a rule called as right hand rule, or it is also called as right hand thumb rule. So we can look at this one. So let me know once you're done.
Done, sir.
Okay. Shall we proceed? Yes. Now the next point is I told you that when you do the cross product between the given vectors, then how is the output going to be? It's going to be a vector quantity, right? And who is deciding the direction of that vector quantity? It is this n cap. Now the next question that we are supposed to ask is how to find the direction of this n cap. So how do we find the direction of n cap? For which we have two rules, of which the first one is called as, I already gave it to you, it's called as right hand thumb rule. And what does this right hand thumb rule actually mean? Okay, or how do we even apply it? For which the statement is given like this. So as the name suggests, you definitely need to use the right hand, no doubt in that. So when you're using the right hand, curl the fingers of your right hand. Okay, you take your right hand and curl the fingers of your right hand in which way? In such a way that they point in the direction of rotation from A vector towards B vector in the smaller angle that is possible. After you curl the fingers, immediately stretch your thumb, and in whichever direction the thumb is getting extended will give you the direction of n cap. So let me explain it to you in a simpler manner. Suppose this is A vector and this is B vector, right? So you need to take your right hand and curl the fingers of your right hand in such a way that you curl it from the first vector towards the second vector. Meaning, if you do A vector cross B vector, then A vector is called as the first vector and B vector is called as the second vector. So when you curl the fingers, let's say you're finding A cross B. When you curl the fingers from A vector towards B vector, you need to curl the fingers in the shortest direction possible. So that is, if I have this as A vector, then I can curl the fingers in this direction, or I can curl the fingers in this direction. So which is the smallest angle that is possible? It has taken place in the anti-clockwise direction. So when you do this, curl the first, hold your thumb. For example, you keep it like this. Curl the fingers of your right hand like this. After this, extend your thumb. So once you extend the thumb, this will be the direction of n cap when you do A vector cross B vector. Means you have actually curled the fingers in anti-clockwise direction. So just to understand this concept better, what we will do is we will try to curl it from clockwise, curl it in the clockwise direction. That is, we will try to find B vector cross A vector, right? So if I do A cross B, I curl the fingers in the anti-clockwise direction. When you do B cross A, this is B vector and this is A vector, right? When you do B cross A, curl the fingers of your right hand in the clockwise direction and extend the thumb. So the thumb is pointing into the plane. Did you observe this? So when you do A cross B, you're getting one direction. And when you do B cross A, you're exactly getting the opposite direction. Right? But the main context that we need to note here is when you want to find n cap using the right hand thumb rule, the first point to be kept in mind is use right hand. Most common mistake is many of them start using their left hand and try to find the answer. You will not get it. So use right hand and try to curl the fingers from first vector towards the second vector in the shortest direction possible. So if it is anti-clockwise, curl the fingers of your hand in the anti-clockwise direction and extend your thumb. It will be mostly in the outward direction. And when you curl it in the clockwise direction, it will be in the inward direction. Make a note of this point. Let me know once you're done. All are done? Okay. Shall we see the next rule also? So I told you there are two rules you can use to find the answer, out of which one was the right hand thumb rule. And let's see the next rule as well. The next rule is called as right-handed screw. So if you have a screw which is to be used by a right-handed person, you call it as a right-handed screw. So basically a right-handed screw is something like this. See, if there is a wall and I give you a screw, and if you want the screw to go into the plane, means if you want it to get pierced into the wall, in which direction will you turn the screwdriver? You will turn it in the clockwise direction. So when you see from this side, you turn it in the clockwise direction. Whereas if you want to bring it outside, you're going to turn it in the anti-clockwise direction. That kind of a screw is what is called as a right-handed screw. So the best example for that is the water bottle cap. See, every water bottle that is designed in this world is based on this right-handed screw rotation. So if you want to open the water bottle, by default, what you do, you turn in the anti-clockwise direction. So when you see it from the top, you turn it in the anti-clockwise direction and you're able to open the cap. Whereas if you want to close it, you are going to turn it in the clockwise direction. You're going to turn it in the clockwise direction when you see from the top, and it is going to get closed, right? So the same logic is borrowed to find the direction of cross product. Okay, so tell me, when you turn in the anti-clockwise direction, what is happening? The cap is coming towards you. When you turn the cap in the clockwise direction, the cap is going away from you. In a similar logic, let's say, I'm coming back to the same point, A vectors, B vectors. When I go from A vector to B vector, if I curl the fingers of my hand in the anti-clockwise direction, the thumb is pointing towards you. Whereas if I curl the fingers of my hand in the clockwise direction, it is pointing away from you. Same logic. Imagine like a water bottle cap. If I keep the water bottle like this, if I have to open the cap, I'm going to turn it in the anti-clockwise direction towards you, clockwise direction away from you. So to conclude the whole story, throughout physics, when you turn something in the anti-clockwise direction, it is considered to be positive. Because this direction by default is considered to be positive z direction. And the other direction is considered to be the negative z direction. So having said this, let us see what is the statement for right-handed screw. So if a right-handed screw is placed with its axis perpendicular to the plane of A cross B, means if this is the plane which contains A vector and B vector, I take a screw and I place it perpendicular. Imagine a screw in your hand and it is placed perpendicular. If it is rotated from A to B through the smaller angle, then the direction in which the screw advances gives the direction of A cross B. Means, if you keep it in the direction perpendicular to it, if you turn the screw in the clockwise direction, means you're turning from B to A. Suppose, if you're going in the anti-clockwise direction, you're turning from A to B. So when you turn it in the anti-clockwise direction, that direction gives you the direction of n cap. That is what they mean by the statement. So make a note of this. Are you guys able to visualize it? Right? This is one of the slightly toughest concepts, so make sure you understand this. Okay. Those who are online, could you understand this?
Yes, sir.
Yes. So I have a doubt, sir.
Tell me.
So if we take the case of the steering wheel, sir, can we relate to this, sir?
Yeah, steering wheel, same logic, no?
Yes, sir. When we turn the steering to left side, the wheel
You
moves
turn
to the left.
anti-clockwise.
Yeah, and clockwise, if we move, it will just turn right.
You turn it, when you turn the steering wheel to the right, you're actually creating a clockwise. There is something called as a word called as torque.
Yes.
I'll explain what the torque is. So I hope everybody made a note of it. There we go. Shall we proceed to the next part? So here, the point that we are supposed to note is the direction of A vector cross B vector is the same as the direction that you get by finding the direction of n cap. So whatever is the direction of n cap, whether you are going to use right hand thumb rule or right-handed screw rule, and find out the direction of n cap. That n cap gives you the direction of A cross B. Is the point clear? Nobody out there. Winter. Audio mattu record out there. Is it clear? So next is we are going to discuss about some physical quantities which can be expressed as the vector product of two other vectors. Okay. So till now we were discussing about the different kinds of vectors as A vector and B vector, but this A vector and B vector can be any two vectors which represent a physical quantity, of which the first one that we can think of is a physical quantity called as torque. So torque is defined like this. The torque acting on a particle is defined as the vector product of its position vector and force vector. So position vector is R and force vector is F. So if you write R vector cross F vector, you call that as torque vector. Okay. So torque is one such physical quantity which is actually the result of cross product of whom? The position vector and the force. Right. About this, we will be discussing under a chapter named System of Particles and Rotational Motion. Okay. And the next physical quantity that we can think of is called as angular momentum. So in your lower grades, you would have learned about linear momentum, which is defined as a product of mass and velocity. So now we are going to discuss about the concept called as angular momentum, which is represented by the symbol capital L, and it is given like this. The angular momentum of a particle is basically the cross product of two vectors, namely position vector and linear momentum. So here observe, here it is position vector cross force vector in the case of torque. Whereas in the case of angular momentum, it is position vector cross linear momentum vector. Is that clear? Done? Done. And the third example of such physical quantity is called as instantaneous velocity. Right? So this instantaneous velocity is not the one which we are defining with respect to linear motion, with respect to circular motion. So it is defined like this. The instantaneous velocity of a particle is defined as the cross product of its angular velocity. Means the velocity which is defined in the circular motion, angular velocity and position vector. So V vector is given as omega vector cross R vector. So this is another physical quantity which can be expressed as the cross product of two other physical quantities. But when you express cross product, what is the important point to be kept in your mind? You need to ensure that both are vectors. You cannot express the cross product between two scalar quantities. Is that clear? proceed? So what did we see? We saw the definition. We saw how to find the direction of NCAP. Third is we saw what are the physical quantities which can be represented as cross product of two other physical quantities. Now we need to concentrate on the next part, which is called as properties of cross product. What are all the different properties it is going to exhibit, right? Of which the first point that you need to make a note of is vector product is anti-commutative in the sense A vector cross B vector is not the same as B vector cross A vector. And what is the reason for it? For the direction change. I told you in the beginning, when you do A cross B, you will get n cap. For example, when we do A like this and B like this, right? When you do A cross B, you will get n cap towards you. Whereas when you do B cross A, you will get n cap away from you. So that is why they clearly mentioned it. A vector cross B vector is not equal to B cross A, but it is the negative of B cross. It is the negative of B vector cross A vector. Make a note of it. Is this clear? Shall I proceed? So the next point says vector product is distributed over addition. Means A vector cross the sum of B and C is the same as A cross B plus A cross C. Second, so A vector cross the sum of B vector and C vector is the same as A vector cross B vector. Means you are distributing that A to each term in the addition process. So A cross B plus A cross C. Is it clear? The third property is vector product of two parallel or antiparallel vectors is a null vector. So you should not tell this, okay? Be careful. Vector product of two parallel or antiparallel vectors, you should not see the zero. Because zero is a scalar value. But what is the cross product going to give you? Cross product gives the output as vector. So you should not use zero. Rather, you should be more specific in using the word null vector. Because the output is also a vector. Right? So A cross B for two parallel or antiparallel vectors. For parallel vectors, what is going to be the angle between them? Obviously, so if two vectors are parallel, what is the angle between them? Zero. If two vectors are antiparallel, angle between them is 180 degrees. So if you see the trigonometric table, sine 0 is a 0 and sine 180 is also a 0. That is why if you see A cross B is written as AB sine 0 or sine 180 times n cap. Both of them are going to give you 0. Answer is. So how do you write it? 0 with the bar on top. So the next property So the next property is vector product of a vector with itself. So if you take a vector and do the cross product of that vector with itself, that will also give you a null vector because the angle between a vector and itself is also going to be 0 degrees. Right? So this is another important point. Should I proceed? Now, what about the vectors being perpendicular? Suppose you have two vectors which are mutually perpendicular vectors, and you want to find the magnitude of the cross product. You're not finding the cross product, you're finding the magnitude of the cross product of those two vectors is perpendicular to each other. Then what is it that you're going to get? Is equal to the product of their magnitudes itself. Why is it so? Because when you do A vector cross B vector, what are you going to get? You will get magnitude of A into magnitude of B into sine theta. In this scenario, what is the value of theta? 90. So what is sine 90 going to give us? 1. Right? And actually you're supposed to have an n cap. Is that right? So you will have AB sine 90 n cap. But what are you actually trying to find? You're finding the magnitude of it. So magnitude of A is A only. Magnitude of B is B only. Sine 90 is 1. And what is the magnitude of n cap? That is also 1. Because what is the name of n cap? It's the unit vector. Magnitude of unit vector is 1. So that is why they are saying the magnitude of the vector product of two mutually perpendicular vectors is simply the product of the individual magnitudes. Okay, make a note of this point. Clear? Noted? Shall I proceed to the next one? Now listen. So vector product of orthogonal unit vectors. What are the orthogonal unit vectors? I cap, J cap, and K cap. Right? So vector product of orthogonal unit vectors, that is the magnitude of each of the vectors I cap, J cap, and K cap is 1. And we know that the angle between the orthogonal itself means perpendicular. The angle between them is going to be 90 obvious. So from the previous point, if I borrow the concept, the previous point speaks about the fact we are finding the magnitude of perpendicular vectors, magnitude of cross product of the perpendicular vectors. Whereas here, you are finding just the cross product of two perpendicular vectors. Means I cap cross J cap should give you what? Magnitude of I cap, which is 1. Magnitude of J cap, which is 1. Sine of what is the angle between I and J? 90, sine 90, and what is that you have extra? N cap. Right? So 1 into 1 into sine 90 is 1 times n cap, and that is going to give you n cap. So when you do the cross product between two orthogonal unit vectors, you will get a vector n cap, which is mutually perpendicular to whom? According to the definition of cross product, n cap is a vector which is mutually perpendicular to both the vectors for which you're doing the cross product. That is what is given in the first point. Did you observe? So in the definition, what did we give? N cap is what? N cap is a unit vector perpendicular to the plane that contains A vector and B vector. So when a vector is perpendicular to the plane, it means it is individually perpendicular to both the vectors. Breathe and point. So make a note of this. After this, there is something important that we need to do. So you're done with this. Now listen to this point. So I told you n cap is a unit vector perpendicular to the plane containing those two vectors. So in the previous scenario, you see I cap and j cap are the vectors which are lying in the plane, right? So, but we know the fact from the orthogonal unit vectors that I, j, and k are mutually perpendicular to each other. So when you do I cross j, so what is the axis? I cross j is presented. I is x-axis, j is y-axis. So I cross j is lying in the xy plane. So what is the vector perpendicular to xy plane? It is z. So it can either be positive z or negative z, right? In that scenario, what is I cross j going to give me? Because I know the fact that A cross B is not the same as B cross A, it is anti-commutative. That's what the first property is. If that is a scenario, then I need to know what does I cross J give me. For that, let us try to visualize. This is my hand. Okay. This is I cap. This is J cap. So I cross J means from I cap, you need to turn towards J cap. In which direction? In the shortest direction possible. The shortest direction is anti-clockwise. So take your right hand, curl the fingers of your right hand in anti-clockwise direction and extend the thumb. The thumb gives you the direction of n cap. So when you do I cross j, what is the direction of n cap? I told you at the beginning, anything towards you is positive. So what z-axis does this represent? Positive z-axis. So positive z-axis is represented as K. So that is why you see I cross J is K cap. Are you guys able to understand those who are online?
Yes, sir.
Yes,
sir.
Yes, sir.
See, actually, there is a mistake here. Write the first one up. Don't copy everything. These are all wrong. Mistake that I observed. So this is repeated. I cross J is K, but I cross K is not I. I cross K is not I. Simply K cross I. This is right. This one is wrong. I cross K is not I. I cross K is minus I. So don't write this part alone. So first I cross J is K cap. Okay. And K cross I is J cap. K cross I is J cap. And J cross K is I cap. J cross K is I cap. Now, if you exactly do the reverse of them, what is the reverse? I cross J, write it as J cross I, you will get minus K cap. J cross K, write it as K cross J, you will get negative Similarly, I cross k equal if you write, sorry, k cross I equal if you write I cross k, it's fine. You need not worry. Okay. So your mind might start thinking, am I supposed to remember all these stuff? There is a shorter, there is an easier way to remember this. Okay. In fact, if you ask me, you need not remember. There is a short, there is a method to recollect it easily. Should I explain that? You're done writing this? Okay. So the concept is how to remember this. What is the aim to remember this? It is simple. Okay. What you need to do is write I, J, K in anti-clockwise direction. Which direction? In anti-clockwise direction. So if you do I cross J means I cross J means you are turning in which direction? You are turning it in the from I to J, which direction are you turning? Anti-clockwise. If you do J cross K, anti-clockwise. If you do K cross J, sorry, K cross I, you're turning in the anti-clockwise direction. And the same IJK written in the anti-clockwise direction, but instead of coming from I to J, you're going from I to K, means you're going in the clockwise direction. And K cross J, you're going in the clockwise direction. And J cross I, you're going in the clockwise direction. If you do that. The logic is I cross J will be, forget these two, for whichever you did the cross product, whatever is left out will be the answer. So I cross J will be K cap, but is it possible or negative? It is possible. Because the logic is very simple. In physics, what did I tell you? Anti-clockwise direction is positive. Remember your water bottle cap. When you turn it in the anti-clockwise direction, it comes towards you. It is positive. So anti-clockwise is positive. So I cross J is K. In a similar way, J cross K will be I. Similarly, K cross I will be G. But everything will be positive because you are doing it in the anti-clockwise direction. And most important rule to be remembered is you should always ensure that I, J, K are written in the anti-clockwise direction. Don't write them in clockwise and apply this rule, you get wrong. Meaning, don't write I here and J here and K here. No. I here, J should be at the bottom, K should be. This is the right way to write. In a similar way, what is I cross K? J cap, whichever is left out. K cross J, I cap, but the negative state. Similarly, K cross J. So I think I asked that. So J cross I, K cap, but the negative state. I hope this is good. There is a very important thing. Done. So now I mentioned it, no, anti-clockwise is positive and the clockwise is negative. So the next property is, so if at all you want to find the vector product of two vectors, right? Can they be expressed in terms of rectangular components? So what do I mean by rectangular components? To put it in simple terms, they are the coefficients of I cap, j cap, and k cap. Suppose a vector is what? Ax I cap plus a by j cap plus az k cap. That is a vector. And b vector is bx I cap plus b by j cap plus bz k cap. Suppose these two are the given vectors, then the a cross b can be written in this kind of a pattern called as determinant. What is the determinant? I'll explain it to you. So what you can do is a cross b is equal to put two lines like this. The first, so horizontals are called as rows and verticals are called as columns. So when you write it horizontally, write it as I cap, j cap, k cap. And in the second, in the first row, you write it as ijk. Second row, write the coefficients of the first vector. That is ax, ay, az. In the second row, write the coefficients of second vector. That is bx, by, bz. If this is the logic, if I want to do b vector cross a vector, what am I supposed to do? So ijk is same. Here what should I write? Bx, by, bz. Here what should I write? Ax, ay, z. So that is the only thing. So order is very important. Okay? I repeated, horizontal are called as rows and the verticals are called as columns. Okay. Okay. Next was, if two vectors are given to you, okay, if two vectors are given in the rectangular components form, but they're asking you to find the angle between those two vectors. So there are two ways in which you can find. One is using the dot product. If you recollect what we did in the case of dot product, it will be cos theta is equal to a vector dot b vector by magnitude of A into magnitude of B. If you want, you can refer your notes once. So what we're getting, cos theta is equal to A dot B divided by magnitude of A into magnitude of B. If you remember, we did problems also in the previous class. In a similar way, you can find it using the cross product also. So one thing I want you to remember is, if you write A cross B without the modulus, then you should put an n cap here. But if you put a modulus to A cross B, then you will remove the n cap here because magnitude of n cap is 1. Okay. So you write it as A vector, magnitude of A vector into magnitude of B vector into sine theta. So what is our objective? Our objective is to find sine theta. So if you rearrange this equation, what will sine theta be equal to? Magnitude of A bar cross B bar divided by magnitude of A into magnitude of B. And remember, wherever you see magnitude, they are just numbers. Without the modulus, they are numbers. So this is a very, very, very important for the writer. Is it clear, guys? Shall I proceed? Next is the next kind of property. So I think there's the last one. Yes, there's the last property. In some of the problems, what they will do is they'll give you a vector and b vector. So whenever you have only two vectors, remember, whenever you have only two vectors, you can always draw a plane through them. I'll show you how it works. There's one vector, there's another vector. However, I keep it, okay. If I keep them like this, I can think of a plane. If I keep them like this, I can think of a plane. If I keep it like this, think of a plane. So between two vectors, you can always draw a plane. And when you draw a plane, there will definitely be a vector which is perpendicular to these two vectors. Now, there is a question, okay. Let's say I give you two vectors in hand, and I'm saying, find out the vector which will be perpendicular to both these vectors. Then what is the only tool you have in your hand? What is the only tool? What do you do to both those vectors? I repeat it, listen to the question carefully. I give you two vectors, A and B. I'm saying, find the third vector which is perpendicular to both these vectors. What will you do? Simply find the cross product between them. Because what does the cross product tell us? Cross product will give us the third vector which is perpendicular to both these vectors. So cross product gives a third vector which is perpendicular to the plane containing these two vectors. Plane containing now, it is perpendicular to individual vectors as well. If that is the case, now read the statement carefully. If I want to find a unit vector which is perpendicular to whom? Perpendicular to the plane that contains the two vectors. Who are those two vectors? A vector and B vector. Suppose A vector and B vector are in this plane. I want to find a vector which is perpendicular to this. Then what will I do? If I want to find only the vector, do the cross product. If I want to find the unit vector, do the cross product and divide it with the magnitude of the cross product. Because A cross B will give you C vector. See, for example, if we call A cross B as C vector. Listen to my question carefully. A cross B is C vector. So what is C cap? If there is a vector A, how will you find the unit vector of itself? I already gave you the definition. Go to unit vectors and tell me. A vector by magnitude of A vector. Meaning, if A cross B A cross B is, let's call it as C vector. So if I want C cap, what should I do? C vector divided by magnitude of C vector. That is what we are doing here. But what is that C vector actually? C is actually A cross B divided by magnitude of A cross B. Okay. So read the statement, underline the word unit vector perpendicular. So if you want to find the unit vector perpendicular to the plane that contains the two vectors, then you do this kind of an operation. Here. right? So you remember the determinant concept. I told you, I explained it to you. We wrote it as determinant of ijk, ax, ay, az, kx. I'm reading modulus. We read it as determinant of. You not read it as modulus. And that is related to a concept called as matrix, which you learn in your 12th standard. As of now, you know how to handle the determinant sets. Right? So what are we saying? Vector product of two vectors can be expressed in terms of their rectangular components as whom? As a determinant. So how do you do that? Suppose I have a vector and b vector, which are individually written as ax I cap plus ay j cap plus az k cap, and b vector is written as bx I cap plus by j cap plus bz k cap. Make a note of this point. Write out the heading and make a note of this point. Clear? So my job is to find a vector cross b vector. Right? So what is a vector? Just now look at it. It is ax I cap plus ay j cap plus az k cap cross bx I cap plus by j cap plus bz k cap. That's simple. I have 3 terms here and 3 terms here. When they are going to get multiplied, I'm going to get 9 terms. I'm supposed to be in those 9 terms. And how am I going to get those 9 terms like? First is this ax I cap will individually get multiplied with this whole thing. So what I wrote is ax I cap cross this whole thing, bx I cap plus by j cap plus bz k cap plus ay j cap should get multiplied with the whole vector. So ay j cap plus cross bx I cap plus by j cap plus bz k cap plus az k cap to get cross this vector bx I cap plus by j cap plus bz k cap. When I multiply these two, what will I do? Ax and bx are scalar parts. Cross product is applicable only between vectors. So all the vectors associated together. They are I cap and I cap. So the first term, what is it going to give me? It will give me ax into bx, I cap cross I cap plus ax into by, I cap cross j cap plus ax into bz into I cap cross k cap. Any doubt here? Is it clear? Plus you go in a similar pattern, what will you get? Ay dx j cross k. I told you, remember that order is very important. That is j cross k plus ay by. There is a mistake. Can you correct it? There is a mistake here. Can you correct it? Ay by j cap, here it should have been j cap. So there is a mistake here. That part alone I want to note it down from again. J cap cross j cap plus ay bz j cap cross k cap plus third one az bx k cross I plus az by k cross j plus az bz k cross. Right? So first make a note to this one. possible to look at the board. Clear? I hope it's done. So comprehensive, you should have 9 terms. Was wrong like done? Shall I proceed? No, if you reconnect from the property, there was one such property like this. If you do the cross product of the vector with itself, what would be the output? A null vector. Reason? The angle between the vector and itself is going to be 0. Sin 0 is going to be a 0. So here, out of these 9 terms, how many terms do you get are going to get eliminated? So are there places where you're doing the cross product of the vector with its which place? I cap cross I cap, j cap cross. So here I hope you guys changed it. J cap cross j cap become, right? And k cross k. So they should get eliminated. And see, they are going to give you a 0. So how many terms are you left over? 6. Okay, the step is validated. Now, what is I cross j? Recollected from that clock. You should write I, j, k in the anti-clockwise direction. I cross j is k cap. So I cross j is k cap. Okay, then I cross k. I is here, k is here. I cross k is negative j. So minus j. Okay. J cross I. So you need not break your head. Once you wrote I cross j as k cap, j cross I will be minus k cap. Sorry, this is gone. J cross k. J is at the bottom, k is here. From j to k, you go in the j cross k is I cap. Correct? Adhe k cross I. See, I cross k already wrote it. I cross k is minus j cap. So k cross I will be plus j cap. So k cross j, you already wrote j cross k. J cross k is just what you told me. J cross k is I cap. K cross j is minus I cap. All 6 are gone. So when you write it in this form, you should get a symmetrical function. If you have plus k cap, There you have xy. Ax by has plus k cap. Then ay bx will have a minus k cap. Where is it? So ax by has a plus k cap. Ay bx has a minus k cap. It follows symmetry. Similarly, ax bz has minus j cap, and az bx will have a plus j cap. Similarly, I cap is there. Where is I cap? Ay bz is I cap, az by is minus I cap, and the remaining three are 0. So three terms will have positive I, positive j, positive k. Exactly the symmetrical terms will have negative I, negative j, negative k. Are these two steps clear? Right? Make a note of this. Good one. So whichever quantities are seen, I can't write it here. I'll follow this. These quantities are zero. Either switch your arrow, can arrow mark like this and put a 0 on top of it. So cut that value and write that 0 on top. Clear. See, this can be further written as collect all the items. When you collect all the items, first term will be what? Where is I? You have a by bz minus minus az by. Okay. First I with positive value. Then collect minus j terms. I'll tell you why minus j. Okay. As of now, write it as minus j ax bz minus az bx. Then put a plus sign for k, means alternate signs. Plus, minus, plus. Okay, plus k cap into collect the terms. K cap. So k cap is here. Ax by minus ay bx. Okay, and this whole thing is actually the resultant of a cross b. That's what you yourself will write. Right? You got an expression. So what it is. Fortunately, there is a concept in mathematics which actually gives us a value when you expand it. This is an expanded value. If you are able to condense and write it, then you write it in this form, which is called as the determinant method. That was the property that we discussed. So when you expand the determinant, you actually get this value. How to expand that issue? That I will. But if you condense and write it, you write it in this way. How do you write it? I cap, j cap, k cap in the first row. So I, j, k in the first row, ax, ay, az in the second row, bx, by, bz in the third row. Okay. Make a note of this. Clear, guys? Right? So the next point is how to find determinant. After this, I have some problem which are connected on this. So how to find determinant? I'll explain it now. I have to connect another device. Just give me a minute. Not working.
Recording in progress.
So right now the heading is how to find determinant. So how to find determinant. Suppose I have I cap, J cap, and K cap. And what do I have here? AX, AY, AZ, BX, BY, BZ. Suppose I have something like this. What I need to do is write I cap. So before that, put a plus, minus, and a plus sign on top of I cap, J cap, and K cap. Why you are getting it? I have to get into the mathematical details. You'll learn it in detail next year. There is a concept called as cofactors and minors, which will explain you. That is not your headache at this point. If you're able to solve the problems in physics, you're sorted. So for I cap, what is the sign? Positive. So open a bracket. Hide the row which contains I cap and hide the column which contains I cap. Meaning, hide this row and hide this column. So what are you able to see? AY, AZ, BY, BZ, right? Just cross multiply them. So start from left to right. AY, BZ minus AZ, BY. Is the first step here? Okay. Second, you should put j cap. Obviously, after I, you have j. But what is sign for j cap? Negative. Put a bracket. Hide the corresponding row and the corresponding column. What are you able to see? AX, AZ, BX, BZ. So what are you supposed to do? AZ into, sorry, AX into BZ minus, okay, I can write it as AZ into BX. Can I do this? Plus K cap into, what are you supposed to do next? Very good. So K cap means hide the corresponding column and the row. You have AX BY minus AY BX. Okay, even before you copy it, check if this expression is matching with the expanded value that we put in the previous step. So I into AY BZ minus AZ BY. Was it there? Minus J cap into AX BZ minus AZ BX. Is it there? Yes. Plus K cap into AX BY minus AY BX. That's how you find the return. Purida? This is all about cross product. As I told you, this is a slightly complicated concept. That's why I have to be in depth. There's a lot of applications here. So to make you more confident, tomorrow I'll solve around 8 to 10 problems based on this. Any other doubt? So that's it for today. The next class we'll discuss about, we'll solve some problems followed by the next concept. Next concept I'll give you is relative velocity. Or is that start circular motion. After that, I put the relative velocity.
Can you grab
Okay.
so that's big.
That n cap is what is K cap. That's what we remitted. Sorry.
They're both same numbers.
Yeah, they both the same. See, the previous step what we do is I cap cross J cap is equal to magnitude of I cap, that is 1, into magnitude of J cap, that is also 1, into sin 90, and what I left out with n cap. So in the next step, we are trying to find out what the n cap actually is. Prida. Who's online? I hope you're clear. So online, are you clear?
Yes, sir.
Okay, we'll wind up.
Thank you, sir.
Yeah.
Thank you, sir.